So students, now let's start activity 1.5, arithmetic progressions. So first of all, let's know what is an arithmetic progression. So a sequence in which each term differs from its preceding term by a constant. So, an arithmetic progression is a sequence in which each term differs from its preceding term by a constant value. Then, the sequence is called arithmetic progression. It can also be written as, we denote it as AP. Consider a list of numbers like A plus D, A plus 2D, and so on. So you can see each term differs by a common difference, that is D, where A is called the first term, A denotes first term, and D is the common difference. So, a given list of numbers A1, A2, A3, A4 are in AP, then A2 minus A1, A3 minus A2, A4 minus A3, must have same value, or you can say must be same. Because this gives us the common difference D. So students, our objective for this activity is to verify that the given sequence is an arithmetic progression by paper cutting and pasting. Method. Now let's see the procedure. So the procedure for this given activity is step 1. Let a sequence of positive numbers three, 6, 9, 12, 15. Step 2. Take a rectangular strip from a colored paper of width 1 unit and length 2 units. Step 3. Take another rectangular strip of dimension 1 into 3, 1 into 6, 1 into 9, 1 into 12 and 1 into 15 units respectively of different colors. So the different strips we would get would be somewhat one into 3. Similarly, one into 6, one into 9. So in this way we have our strips and these are of different colors. Similarly, you can get for 1 into 12 and 1 into 15. Now paste these colored strips in order on a squared paper. Suppose So suppose this is our squared paper, and now we'll place the strips. So our first strip is 1 by 3, and here each square is of dimension 1 by 1. So now we have a square grid paper as shown here, and now we'll paste the strips. So our first strip was of dimension 1 into 3. So let's shade the portion 1 into 3. And our next strip of paper is of dimension 1 into 6. So our next strip is 1 into 6, so we paste it in the second column. So here the difference between the two is 3 units. Similarly, our next step is of dimension 1 into 9. So now pasting it here, 1 into 9. You can again see the difference between the previous and the strip of dimension 1 into 9 is again 3 units. It is 3 units greater than the previous strip of dimension 1 into 6. Now next strip is of dimension 1 into 12. Again, this strip is 3 units greater than the previous strip. That is, the length is 3 units greater. The next strip is of the dimension 1 into 15. So let's draw. So now again you can see the difference between the strip of dimension 1 into 15 and the previous strip of dimension 1 into 12 is again 3 units. That is 3 square boxes. So you can see the difference between each strip is same, that is each preceding strip have a difference of 3 units. So we can say these 3 strips are in arithmetic progression. We can say the numbers 3, 6, 9, 12, 15 are in arithmetic progression, as the difference D, that is common difference, is same. Now step 5, take another sequence of numbers say 1, 3, 6, 7, 9. Step 6. Take rectangular strips from a colored paper. Of length 1 units, 3 units, 6 units, 7 units, 9 units. Step 7. Paste colored strips on a squared paper. In a order. So students, our first dimension, that is first color strip, is of dimension 1 into 1. So let's color. So this is our first strip of dimension 1 unit. Our second strip is of dimension 1 multiplied by 3. So second strip is to be pasted, and our third strip is of dimension 1 multiplied by 6. Our next strip is of dimension 1 into 7. Our next dimension is 1 into 9. So in this way, we have pasted all the strips of dimension 1, 3, 6, 7 and 9. And now we will see strip 2. That is second strip and first strip has a difference of 2 units. Second and third strip has a difference of 3 units. Third and fourth strip has a difference of only 1 unit. And fourth and fifth strip has a difference of 2 units. So in this way, we can see every consequent strip has a difference, that is common difference, that is different. But in this case, we have a same common difference that remains constant throughout. So we can say that this progression is arithmetic progression as compared to this progression. So our observation for the given activity is, in case of sequence 3, 6, 9, 12, 15, we can clearly see that the difference between the heights of the adjoining strips is constant. That is 3 units. Therefore, we can say that the given sequence is in AP, that is arithmetic progression. Whereas in case of sequence one, 3, 6, 7, 9, the difference between the heights of the adjoining rectangular strips in case of sequence 1, 3, 6, 7, 9, the difference between the heights of the adjoining rectangular strips is not constant. Therefore, we can say that the given sequence is not in AP. That is, this is not an arithmetic progression. So, what we come to know through our observation that the series where each preceding term has a difference that is same throughout the series, we can say the series is in arithmetic progression. As here you can see the difference between each consequent terms are same in this series, so we can say the series is in AP. As you can see, there is difference of 3, and between 6 and 9 again 3, 9 and 12 again the difference is 3, and here also from 12 to 15 the difference is 3. So it remains constant throughout the series, which is known as common difference, that is 3. So we can say the above sequence is in arithmetic progression. This is how we define an arithmetic progression.